Hi everyone, and welcome back. It's Kira Garfolo here with Greenville Tech's Math 109. Today we're going to continue with systems of linear equations, moving into section 7.2, which is going to help us by applying matrices. So we're going to work with matrix solutions of these systems of linear equations. Now remember from 7.1 that we discussed systems of equations in three variables. So that was, we typically had three equations and we had the variables of x, y, and z. We mentioned row echelon form and the elementary operations that we used to get into that form. So remember that we could switch rows, we could multiply a row by coefficients, or we can multiply a row by coefficients, add it to another row, and replace that row with the result. Now, that's simple enough. It's just a lot of math. It can be a lot of trial and error to find row echelon form. But what if there was another easier, calculator-friendly way that would let the calculator do all the work for us? I would certainly be interested in that, and I'm sure that you would. So that's what we're going to do today. We do have to go over some background information first. So first, what is a matrix? No, not the 90s movie, for those of you who are as old as I am to remember that. But in terms of mathematics, what is a matrix? So a matrix is an arrangement of numbers into rows by columns. We say that the dimensions of a matrix are m by n, where there are m rows and n columns. Sometimes you'll see that in terms of R by C, which I guess is better and more intuitive because R is the number of rows and C is the number of columns. Basically, when we say that we have an m by n matrix, we're just saying, hey, our matrix has this many rows and this many columns. We can see some examples on the next slide. So here's some examples of matrices and their dimensions. In this first one, we have a 2 by 3 matrix. We have 2 rows and we have 3 columns, 1, 2, 3. In this next one, we have 1, 2, 3, 4 rows and only 2 columns, 1, 2, and so on. Here's a 1 by 3 matrix because we have 1 row and 3 columns, 2 by 2, 2 by 1, and 3 by 3. Now, there are a lot of things that go with matrices. There are a lot of different forms of matrices. There are a lot of different things that you can see, you know, column vectors and scalars and square matrices and inverse and identity. We aren't going to cover those in this class. Some of those get covered in 110, which is our sister course, but we don't cover them in 109. What you should be careful though, just like in 7.1, is if you are using Google or any other search engine to look up some of these pieces of information about matrices, just be careful that you don't get in too deep. Restrict your searches to everything that we have covered only. Now, an augmented matrix is the matrix that we're going to use to represent our system of equations. So we're constructing a matrix to represent the coefficients from the system of linear equations. You want to make sure first that you're listing your equations in the same order of variables. So if your first equation is x plus y plus z equals something, make sure that all of your other ones are in terms of x first, then y, then z. Also, if one of your equations doesn't have a y or doesn't have an x or whatever, you want to make sure that you're using 0 for that coefficient. Remember that just because x isn't there doesn't mean it's not represented at all. It just means that it's 0x. So let's look at an example. Remember our system from last class where we were building sheds. We had the system over here on the left. 20x plus 30y plus 40z equals 560 was our first one, and so on for our second and third. We can represent these in a matrix. Specifically, this is an augmented matrix because our solutions over here, our answers, our constant terms, are also included in the final column. So 20x plus 30y plus 40z equals 560 becomes the first row in our augmented matrix. Remember, we're just putting the coefficients. So we have 20, 30, 40, and 560. You can think of this column as the X column, this column as the Y column, and this column as the Z column. While this final column in an augmented matrix is going to be your solutions. Not your solutions in terms of X, Y, and Z, but your constants on the other side of the equals term from the original system. You can see that you can do the same with 10, 20, 30, 380, and 30, 30, 50, 680. Make sure that this makes sense. Make sure that you can write this. You can pause and cover up this matrix and rewrite it just from the system. However you want to practice, just make sure that you're getting some practice here. Now, just like before, we can use elementary operations on the rows of these matrices. You'll notice that this is very familiar to 7-1. Instead of talking about what we're doing with each equation, we're going to be talking about what we do with each row. So we can swap two rows, which is effectively swapping two equations like before. We can multiply a single row by a non-zero coefficient. Remember, this is just like we can multiply an equation by a non-zero. And we can also multiply a row by that number, add it to a second row, and replace the second row with the result. Now, again, we can do these by hand. They're not too difficult in the math world. They're just a little bit of, I don't know, tedious, trial and error if you're trying to get it into a certain form. And that can spend a lot of time. So instead, we're going to talk about entering a matrix into our TI 83 and 84, and then we're going to talk about how we can use some of that information. Now I'm going to talk about the information here and the steps that you'll use, and then I'm going to show it in real time here in a moment with our emulator. So you're going to press second matrix, which is the X to the -1 button, the inverse X button. You're going to scroll over to edit, and you want to select the matrix you wish to enter. A lot of times I'll just use A. You're going to enter the dimensions and the elements. So remember, the dimensions are in row by column. So how many rows do you have? How many columns do you have? And then you're going to enter your elements. Once everything is there, you can exit with pressing second and then quit. Now, once we have our matrix in there, there's a lot that we can do. We can find the row echelon form directly. This makes our lives so much easier. We don't have to mess around with any of that math by hand. So after you get your matrix entered, we are going to use the math functions in the calculator to do all the work for us. Notice that this means that it requires 0 row operations on your part. And if you haven't figured it out yet, this is why I said to wait to do your 7-1 homework until after you saw this section. Hopefully you heeded my advice. The steps to do this are very similar. We're going to go into matrix by pressing second matrix. We're going to scroll this time to math, and you're going to scroll to REF, and you'll press enter. Now that's going to say, okay, you want the row echelon form of something. You're going to have to go back into second matrix and select your matrix on that first screen and press enter. When you close the parentheses and press enter, voila, it's going to output it for you directly. Now it's going to, by default, unless you've put your calculator into exact form, which is good in some cases and bad in others, excuse me, it is going to give you the decimal form, not the fraction form. If you don't want to go change the mode of your calculator, no worries. You can just press math, frac, and enter. That's the first one when you press math. So you're just going to press the math key and press enter, enter. And it's going to output it again, except it'll use it in fractions instead of decimals. Now, all of that sounds probably very confusing if I'm just telling you the instructions. So let's walk through an example. Let's find the REF of our earlier matrix. Okay. So we need to have our earlier matrix up here for reference. Remember that this is the matrix that we're working with here, okay? So 20, 30, 45, 60, 10, 20, 30, 380, 30, 30, 50, and 680. I'm going to pull the emulator up. And I am going to go to matrix. Notice that matrix is in blue right here. So I'm going to press second matrix. And I'm going to scroll over to edit. And I want to edit this first one. We're going to let it be A. Now notice here that I have 3 rows and 4 columns. So I'm going to tell it that I want a 3 by 4 matrix. And it's going to set it up for us. So we want 20, 30, 40, 560, and then 10, 20, 30, 380, and lastly 30, 30, 50, 680. Now I can get out of this by just saying, okay, quit, go back to where you were. If I want to see it again, I can go back to matrix. And just this first screen lets me select it. And I'll say, yeah, sure, show me what A is. And it's going to output it for me. If you ever need to double check and don't want to go through edit, just ask it to regurgitate it for you. Now we want to find the row echelon form here. So we're going to go back into the matrix menu, so second matrix. And we're going to scroll over to math, this heading right here. And we're going to scroll down. This is a lot of stuff that we don't actually do in our course. But if we scroll down, you're going to see option A is REF. So press enter. Now it just opens a parentheses for us. If we press enter now, it's going to give us an error. But if we tell it we want the REF of matrix A, so we'll go in the second matrix, or this is how we tell it to just recall one of the matrices. So REF of A, and then close your parentheses so you don't get an error, and press enter. It's going to give us our solution. Now again, notice this is in decimals. You can scroll over if you need to see more of it, because our solutions are way over there, right? But if we want to put this in fraction form, we can simply press math. Notice it's already on frac, so we'll just press enter and press enter again, and it'll output it for us in fraction format without changing the actual mode of our calculator. I prefer to keep it in approximation mode just because I like to work with decimals. A lot of what I do in statistics is decimals. And so I just ask for fractions when I need it. This is always a good way to do that. Okay, so here is the row echelon form of that matrix. We see that the first coefficient is 1 in each case, which is what it should be for row echelon. And we see that there's nothing preceding that 1. This one starts with the X. This one starts with a Y because there's a 0 over here, and this one starts with a Z because there's nothing but zeros over here. Now notice that we can transform this back into a system of equations, because this is the value of, this is something times Z equals this. These are the coefficients. We're just working with the coefficients. Let's go back over here and see. So here was our matrix. And here's what we got for row echelon form. Typed out, our row echelon form is 1, 1, 5/3, 68/3, 0, 1, 4/3, 46/3, and 0, 0, 1, and 7. Now, we can work backwards, as I was saying, to turn this matrix back into a system. Remember that these are the coefficients for X in this first column. These are the coefficients for Y, and these are the coefficients for Z. Well, these numbers are on the other side of the equal sign. So we have Z equals 7 because these are zeros and this is a 1. So Z equals 7. Y plus 4/3 Z equals 46/3. And X plus Y plus 5/3 Z equals 68/3. Take a moment, pause the video if you need to. Make sure that you can walk through this and transform this into this and vice versa. Going from matrix to equation and equation to matrix should be like second nature. Now we're back to where we were in 7.1. You can back substitute. You start with z equals 7, plug that into this one, y plus 4/3 times 7 equals 46/3 to solve for y. And then once you have y, you plug y and z into this one to solve for x. Take a moment, pause the video, and make sure you can do this. You should get the exact same answer that we got in our earlier section. You should get x equals 5, y equals 6, and z equals 7, just like we did before. Now, if you want to make this even easier, we can further convert our row echelon form matrix into something called reduced row echelon form. And in reduced row echelon form, our final column gives us the answers for each variable. Here, we can use our calculator. We can also get it just as easily, keep on going from REF, keep using those row operations, keep substituting, keep working with it back and forth to get into that format. But for our course, using the calculator is the way I would go. So instead of asking for REF, now you're going to ask for REF in the calculator. It's going to be right below your REF. And now we're going to try it with our earlier example. Let's take a look. We already have our original matrix in as A. So we're going to go into second matrix, and we're going to go into math, and we're going to scroll all the way down until we see RREF. So there's REF, and here's RREF. We're going to press enter. We're going to say, hey, we want RREF of matrix A. We'll close our parenthesis, and we'll press enter. And we see this matrix: 1, 0, 0, 5, 0, 1, 0, 6, and 0, 0, 1, 7. So this is going to say 1x plus 0y plus 0z equals 5. So that says, hey, x equals 5. 0x plus 1y plus 0z equals 6. So hey, y equals 6. And lastly, 1z equals 7, so z equals 7. Notice here that it gives us the answer. So this is what is output by our calculator, and this is what we can tell from it. X is going to be 5, y is going to be 6, and z is going to be 7. So really, once you have that system of equations, if you can get it into matrix format into your calculator, and then use the reduced row echelon form, there is very little math on your part. You can let the calculator do the work for you. Here's z, here's y, here's x. Now, similarly to just the row echelon form, that last row is going to give us some important information. It's going to give us the same information, actually. If we see that z equals some number, then the matrix gives us the solution right away. In our example, we had this case. It gave us the value for z, it gave us the value for y, and it gave us the value for x. On the other hand, if our bottom row is 0 equals 0, remember that we have a dependent system and there are infinitely many solutions. And similarly, if we get 0 equals 1 or 0 equals 5 or 0 equals any non-zero number, there is no solution and we have an inconsistent system. So you can see that we're doing the same thing that we did in 7.1, but it's made us so much easier by doing terms of matrices, because then we can use our technology to do the hard work for us. Okay, so now we're going to work through a couple of examples. We want to solve this system and indicate if it has infinitely many solutions or indicate that it has no solution. So the first thing we're going to do is put it into a matrix form in our calculator. And then we're going to put it in RREF. And then we're going to state the solutions. Take a few moments, pause this video, work through it and see if your results agree with mine. I am going to take us to the calculator screen. Oh, that's not what I wanted to do. I was trying to hide what we have, but that's okay. Okay, so we are going to end up with this matrix. Make sure that you can end up with this matrix for A, because remember it's 4x plus 3y plus 2z equals 1, x plus 2y plus 3z equals 4, 9x plus 8y plus 7z equals 6. Make sure that you can get that from that original set of equations. Now, we're going to go into second matrix, and I'm going to edit B this time, and I'll leave A alone. So in B, yet again, we have 3 rows, and we have 4 columns, and we have 4, 3, 2, 1, 1, 2, 3, 4, 9, 8, 7, 6. And all we want here is to get the reduced row echelon form. So we're going to go to matrix. We're going to scroll over and scroll all the way down to RREF. And now remember, we put this one in B. So we'll tell it that we want B. We'll close our parentheses and press enter. And we see that we get this matrix. So 1, 0, negative 1, 2. That tells us x plus 0y minus z. So x minus z equals negative 2. This tells us that y plus 2z equals 3. And this bottom row is what we want to look at to pay close attention. It's a good idea to look at the bottom first, to be honest, to know what kind of solution you're dealing with. Because if there's no solution, then we can jump straight to that conclusion. Here we have 0, 0, 0, 0. So this tells us 0x plus 0y plus 0z equals 0. We're left with that statement that 0 equals 0, which remember gives us a dependent system, which tells us there are infinitely many solutions. If we want to write it in terms of the system and not just the matrix, this is what we get. And since that bottom row is 0 equals 0, we know that there are infinitely many solutions. In other words, this is a dependent system. Let's do another example. We want to solve this system and indicate that it has infinitely many solutions, or indicate that it has no solution at all. So we're going to go into the calculator. And this time, I'm going to put it into C. So I'm going to go into matrix again, scroll over to edit, and I'm going to scroll down to C. Yet again, I have a 3 by 4. And my numbers are going to be 3, negative 5. Should we use that negative sign? 1, 3, negative 5, 1, 4. And then we have 1, negative 3, 4. With an answer of 2. And in our last row, we see negative 11 and 17. We don't have a Z, so we're just going to put 0 there. Remember, we have to have a placeholder there. So we'll leave 0 there. And that was equal to 5. So that's our matrix. And when we go into matrix math, remember that we can scroll down Oops, I didn't quit. Hold on. I'll leave that alone. So I'm going to go into matrix math. I'm going to hit alpha B here because I know that's where RREF is, but you could certainly scroll. And I am working with matrix C this time. And when I press enter, I get this solution. Now I can do this in terms of decimals. That's totally fine. If you wanted it in terms of fractions, you would just press math, enter, enter, and it'll give it to us in terms of fraction, but it's not going to change what we find this time. If we take a look at that last row, we see that 0, 0, 0, 1. That means 0x plus 0y plus 0z equals 1. We ended up with 0 equals 1, which is not consistent. So we have an inconsistent system, which is going to give us no solution. So on the slide, you'll see the same thing. Our RREF ends up with 0, 0, 0, 1. This tells us that 0x plus 0y plus 0z equals 1, giving us 0 equals 1. So there's no solution. This is that inconsistent system situation. So in conclusion, matrices in our calculators make 7.1 a lot easier. We can do pretty much anything that we could do in 7.1 with a matrix, except our calculator will do it for us, but all the same rules typically apply and they can be used interchangeably. Something also to note is that when you're working with matrices and systems, there are often several correct approaches to a single problem. If you're doing these by hand, sometimes there's several correct ways to go in the order of your operations that you're going to do. So unless the problem specifies, you may use your own preference for how to solve. A lot of you are going to prefer to use RREF all the time. And for the most part, that'll be fine. Sometimes you will be asked to find the REF and you might be asked to back substitute. So you should be prepared to do those. But remember, even if you're asked to solve with back substitution, you can always take the time to find the RREF and double check your solutions. I always do that still. And as always, practice, practice, practice. The only way to get better at math is to do math. So work through these examples, pause the video, don't work along with me because it's very easy to see, okay, yeah, that's how I get it when I'm walking you through the steps. Starting with a blank piece of paper and starting from scratch to see if you can get the solution is the best way that you're going to get prepared for our test. Make sure that if you need additional help, you work through the problems on your homework, you're struggling with the quiz, whatever it is that you're struggling on. Remember that the Math Center is available for tutoring. They offer online virtual sessions. They also offer in-person sessions. You can drop in for in-person sessions, but it's recommended that you make an appointment. Remember that I have office hours, and remember that there are so many resources for you in our Blackboard shelf for a quick resource, especially if it's late at night or you know I won't be able to respond, you're trying to finish in a hurry. Definitely take a look at those resources as well. Good luck studying. Good luck with this section. And as always, if you need me, you know how to reach me. Have a great day. Be safe. And thanks again for watching.